Hi everybody, welcome to my channel. My name is Dr. Selena Vasquez-Mireles. This video is part of the Algebra 2 Star Review series. Let's get started. Algebra 2 Star Review series, Week 1, Domain. You may recall that we're going to do subject, terminology, assessment, and relevance. This time we're going to start off with terminology. That's critical to this topic. The word domain, when you think about that, really means your area, what you're most inclined to use or consider as your area. There are other words that are associated with the word domain in mathematics. One of them is input, the x-axis, or just the x. The first set, as opposed to the second set. Allowable values. These are all ways that we can think about the idea of domain, or that domain is communicated. Another thing to think about when we think about terminology and we think about domain, we're going to need to think about how we actually communicate the domain. Sometimes we use symbols. Let me get another color. We use symbols. For example, we can use we want to say the all real numbers is the domain, then we might use the crazy R or the bold R. Sometimes it's scripted, sometimes it looks like a cursive, but that's another conversation. We can also use words. So we can write something like all real numbers. We can use interval notation. And with interval notation, this may include set notation. Like the union or the intersection. So we have symbols, words, interval notation. We may want to show it on a number line. So for example, we may have a number line and we might want to say all positive real numbers. So we would say this. And in interval notation, that would look like this. 0 to positive infinity, and you never put a bracket on the infinity, whether it's negative infinity or positive infinity. And then also we can use sets to communicate, either listed or set builder notation. And so, for example, this 0 to positive infinity would look like x, an element of the reals, such that you can use a slash or a colon. X is strictly greater than 0, and then close that. So if you need some more information about set builder notation, just let me know and I'll try to add something in there like that. Okay, so there's terminology. Next, let's do a deep dive into the actual subject content, the actual terminology. The actual idea of domain. Okay, so when we're talking about domain, we can only talk about domain. Well, we should be only talking about domain when we're really talking about relations and functions. So the key idea here is functions. You build up to functions through relations, but that's the key idea. You're gonna, if you haven't already, you're gonna see a lot of key functions, sometimes called as common functions. Parent functions, family of functions that these parents are, etc. And the big assumption here is what values, when we're asking about the domain of these functions, what values are legal, acceptable values for these functions. That's what domain is. That's why we spent some time talking about the terminology first, so we can say that. What is domain? We want to know what those values are that make that work for this function. When it comes to domain, it's really important to talk about not what values work, interestingly enough, but what values don't work. So what values do not work? That's actually an easier question to answer because we know what functions are going to cause us problems. And there's three key functions that are going to be issues when it comes to domain. We're going to have what I like to call domain issues. Number one, radical functions. Radical functions look, to just use the parent function, radical functions look like this. I'm going to use it so you can see. F of x equals to the square root of x. They have a radical, not just any radical, because the cubic function, that's a different story, but the square root or any even root, you're going to have an issue. Why? Because in the reals, it doesn't make sense to take the square root of a negative number. In the real number system, not the complex, that's a different story. But in the real number system, it just doesn't help us to take the square root of a negative number. So here, one of our concerns is going to be, we want to make sure that whatever we're taking the square root of, we got to grab that, we got to pull it out, and we need to make sure that it's greater than or equal to 0. So that's one of our first concerns. The second one, there are three, by the way. The second one, the second one is rational function. Okay. This rational function, again, I'm going to just turn to one of the parent functions called the reciprocal function. We're going to have problems when we try to divide by 0. So we need to make sure that we eliminate those numbers that would make that denominator 0. So in this case, we got to take that denominator, we got to sweep it out, and we got to avoid any numbers that are equal to 0. And the third one is log functions. These are functions that, again, I'm going to turn to one of the common functions. F of x equals to the log of x. That means it's base 10, or we could have g of x is equal to the ln of x. That means it's a natural log. And we can have other bases, but when we write log, that means base 10. When we write ln, that means natural log. We're going to have some domain issues here, But if you're in Algebra 2, which is the focus of this particular topic, you're not going to get to log functions right away. So for all intent and purposes, you're going to get functions that are radical or rational, or any combination of the two. If none of these scenarios occur, guess what? You don't have any issues. You should be fine. You should default to all real numbers. And that's the beauty of what domain is. Even though, again, domain is about all the numbers that work, it's easier to think about all the numbers that don't work. And then you can express your domain. All right. Again, if you have any questions or you'd like to make some comments, there's a comment section in the video. So now let's go to assessment. Now this idea of domain is a big idea, so you will have these kinds of questions on your, even if for Algebra 1, you'll have domain questions on your STAR. On Algebra 2, it's a very fundamental idea to mathematics, the idea of a function and all of its attributes, which includes its domain and its range. And we're not talking about range today, just domain, but it is critical. So let me give you an example. Oh, and you'll see it on your ACT, your SAT. So I'd like to give you an example of one of the questions that you might see. What is the domain of f of x equals to the square root of x plus 2? All right, so you should ask yourself, what function, what parent function is this? And this parent function is the radical function, the square root function. It is one of those concerns. It looks like this one. So what do we need to do? We need to take this value right here, this expression under the radical. We need to take this out, and we need to guarantee that this number is greater than or equal to 0. So that means we need x greater than or equal to -2. Now let's go back and express this in a lot of different ways, right? In all the different ways we talked about when we talked about terminology. So we could write it in symbols. We can say we can use words. We can say all real numbers greater than or equal to -2. We can use interval notation. So here we would say -2, and we're going to use a bracket, comma, positive infinity, and then open parentheses, a parentheses, but actually it's a close because it's on the right hand side. So we never put a bracket on infinity, whether it's negative infinity or positive infinity. So that's how we would write that. Using the number line, which I like to use all the time because it would help me even write the interval. I always try to find 0. I have 1, 2, 3, -1, -2, -3. Show my integers there. I go to -2, and I'm going to use a different color. Let me use blue. -2, and I'm going to shade this in because it's equal to, and I want all the numbers to the right. That's all of this. Okay, I can use set builder notation. So I can write it like this. Open brace or French bracket. X is an element of the reals such that X is greater than or equal to -2, and then I close that. And it wouldn't make sense to use the list method because you'd be writing infinite number of numbers, and that would be very difficult to do. Sometimes, I mentioned symbols earlier, and it'd be hard to write with symbols, but if you really wanted to, sometimes we can say the reals, and we can put a, +2, but we really can't communicate which ones they are. So I would actually argue against this, but I just sort of wanted to see so that you saw that we talked about all these different methods. So I wouldn't use this in this particular case, but any of these other ones would work. And again, this is a very popular question, finding the domain. The key is to find situations where there may be issues. And for you, right now in Algebra 2, we're really talking about 1 and 2. Later, we'll come to the log functions, but for now, this is where you're going to be working on. All right, so I also promised you that I would do something related to relevance, which is extremely important. So that's my next idea here. And when it comes to relevance, I think that it's really important because we actually use the concept of domain in a lot of places in our real world. But one of the ones I think that you can relate to is the idea of a movie theater. In a movie theater, you maybe as an adult, or you probably could go to any movie you wanted to, but if you're still in school and you're of a certain age, you might not be able to go to any movie that you wanted to. And we have a rating system, which is also a nice example for categories when we think about statistics. But in any event, we have, for example, movies can be G-rated, which is a general audience. PG-13, which could mean that there's parental guidance or caution, especially for children under the age of 13. And restricted R. So there might be a theater here, a theater here, showing some movie, and a theater here. And for example, this one may be general audience, this one PG-13. I know there's others, but I'm just using this as an example. And you may find that it would be fine. Everybody can go to this movie. Only those under 12 should be attending this one, and then of course this one I believe is for 17 is the restricted, unless you're with a parent. In any event, so if you're if let's say for example you're in school and you're 12 years old, then you can go to this movie, and you can't go to any of the others. So there's a domain issue, a domain situation that's going on in here. So one of the things you might want to think about when you're trying to understand domain is perhaps think about, just like in a movie theater, there's 3 issues when it comes to domain that you need to consider. Well, one of them is the radical functions, so things with the square root. Another one is rational functions, the ones that have some kind of fraction, ratio actually. I'll just put Z there, and then the logs. They have the word log. Okay, so these are the issues that you have to be concerned with. So when there's a function and you're talking about domain, these are the concerns. If you have this, if you have this, if you have this, you need to be careful what values of the real numbers can go work for each of these kinds of functions, or any function. And if it's any of these, then you need to experience some type, or you need to have some kind of caution so that you don't so that you're include that in your result. Okay, well, thank you so much for your time. I hope this helped. Again, we talked about using our STAR approach. We talked about the subject, the terminology, the assessment. So just to recap, this was our Algebra 2 STAR review for week 1, domain, and we discussed the subject of domain, the 3 ways that there could be some kind of problem. We're going to hold back a little bit on log functions. That'll be coming. The terminology, different words that are used for domain, input, x-axis, actually the x, even the first set, allowable values, the different ways to notate the domain. And I also want to let you know that sometimes when we use these unions, there could be more than 2 or 3 intervals that we're connecting. We looked at an example of an assessment. This is a high probability that you're going to get a test question like this, no doubt. Domain is extremely critical to the idea of functions. And then the relevance, and we compared this idea of domain to a movie theater and being allowed to see certain movies if you're a certain age. All right, thank you so much. Again, be sure to like this video, share it with your friends, hit the notifications so that you can get other videos week by week, and be sure to subscribe to my channel. Thank you so much.